All right. Hi, everybody. I'm Brandy Leroy. I teach social studies at Bangor High School in Bangor, Maine. I'm also an adjunct professor of GIS at University of Maine Machias, where I get to work with both college and high school kids in our early college classes. So I get to do a lot of project-based learning with them, but this is from my GIS class. I'm really lucky. I got a GIS elective this year, and I have 12 kids in the class, and we've been doing some really interesting work. And one thing I've found out is that, when working and teaching with GIS, it's kind of a mess. We're kind of all over the place, and we have a bunch of different projects that we've been working on, and then some of them get put to this back burner and we get working on something else, and the kids will end up coming back to it, or sometimes they don't because they're not so interested in it. But this is something that I have a couple kids who have really kind of been going on it, and it's still a work in progress. They notice that there's been a real uptick in the homeless population in the city of Bangor. We're a fairly small city, but it seems like almost every corner by stores, they were seeing homeless populations, whether they were panhandling, sleeping, just hanging out, walking down the street with shopping carts. So they were a little concerned about that and wanted to know what was going on. It also brought some really great discussions to our class, like, what happens to these people in the winter? We live in Maine. It gets cold here. And they got looking into it and found that there's an organization that actually had been approved for some grants to get some warming stations, but they couldn't decide where to put them. So these students decided that they were going to create a survey 123 and see what they could find about data on where these homeless people were, to see if they could present to the city on the best place to put a warming station for the winter. So they started creating a survey 123. We really talked about what they should include in it. They didn't want to include pictures. This wasn't about, the people themselves. It was about where they are and how we could help them. So what were they doing? Were they panhandling, sleeping? Were they loitering? Were they just hanging out with others, walking down the street? They wanted to know if they were adequately clothed for the weather. We've actually been really lucky here in Maine. It honestly just got cold this week, and for Maine in November, it's still not really that cold. So most of the answers were yes. Is the person adequately clothed? But we've seen some changes in the past week. We put a map on where are they located, and when did you see them, so that they could start to gather that data on when they were seeing people. They found that they found people sleeping more in the mornings on benches versus the afternoon. The afternoon, they found people panhandling more. And they are actually in a process right now because they found some interesting data, and they're still collecting data. But they found some interesting data, so they want to make a time-lapse map. And they're working on that right now to see where these people are on certain days, because certain things have happened around the community, and it's kind of changed the dynamics. So far, we have a heat map, and you can see there are some areas out here on the outskirts, but a lot of them are concentrated right down here. And there's actually a homeless shelter right here, and the police station's right across the road. So far, they're thinking that, it might be a good proposal to put a warming shelter somewhere in that area, but they're still collecting the data. Some things that they've noticed, weather really impacts. There are some days that they didn't see anybody out because it was pouring. Nobody was panhandling because of the weather. They cleaned out the homeless encampment a few weeks ago, and that ended up with an uptake of people sleeping. on benches in parks. So they've noticed those types of things. So they think if they make a time-lapse map, they can actually really start analyzing and digging into some of that data even more. And they really hope to present, they want to do it in December. I think that's a little bit too close. I'm thinking January, but they want to present it to the city council to see if they can get some warming stations put in for these homeless people who need to get warm in the middle of January and February. So that's what we're working on right now. I'm going to turn it over to Heidi.
So I've just pulled up my organization gallery, and over the years, the kids have done a number of different projects for another number of different reasons. But I want to tell you about stuff that's not specific to a GIS class to begin with. In my AP Environmental Science class, you have to do a lot of labs. So one of the labs is on soil texture. So the morning of that lab, I decided, you know what, we really should make this a GIS project. So I did a survey 1, 2, 3 for them, gave them the QR code that they could all just pull up on their phone, and then set them loose to go around campus and collect soil types. So they got their soil, they added the water, they shook it up. I don't know if you're familiar with the soil texture lab, where you use a soil triangle to determine what type of soil there is. But they did that, and then the next class they came in, analyzed what soil type they had, and created, put it into a spreadsheet, a shared spreadsheet. I had them look at the map that they made with the survey 1, 2, 3, and look at where their dot was on the map, where they collected the soil, to make sure that their location was accurate, because some phones not so much. So they had to do their own data engineering and correct their location on the map using the, had them sign in and use the measurement tool to see their latitude, longitude. And then I kind of put it all together. We did this for 2 days. We did it once on our school campus, and then the next day we went out and we did it on the park that's right next to school. So when they got all the data in, I wanted them to do an interpolation map, but you can't really do that with qualitative data. So I made a soil code with clay being 1, silt being 2, sand being 3, and then combinations, I just combined the numbers. So when I finished the data engineering on that one, I shared back the CSV file of all the data that they'd collected and the final codes, and I had them do an interpolation map. And I was really surprised at the results. It looks like there's a pattern here, like there must have been a stream flowing through, because right in the center and off to the sides you have clay and silt, and then the other soil types. I mean, it just fit really well with the data. And then I had them play around with the base maps a little bit and change it and make it pretty full. With the APES class, I don't really teach them, heavy duty instruction on GIS, but I do give them a few of the learn lessons that fit the class really well. Like there's one on food insecurity, undernourishment with data from the UN, which works out great. Let's see. So in survey 1, 2, 3, also, when we start the class in the beginning of the year, I'll give them a survey 1, 2, 3, and they filled that out, and I turned that into a dashboard so they could see all the responses. It's really visual. But one lesson that I did a while back was the Winged Ambassador. This is a program through NOAA, and they have 5 different lessons. And the lessons aren't specifically GIS lessons. So I took all the lessons and I added a spatial component to it, because there's a lot of paper labs. And so I just, instead of using colored pencils on a paper map, I turned it into a GIS map. In fact, I contacted them and they gave all the the data in an Excel file after I showed them what we were doing. Lesson 3 talks about ocean hotspots. So guess what? Esri's got a hotspot tool that we used for that one. And then the bolus analysis, if you contact them, they'll actually send you a real albatross bolus that the kids can dissect. If not, they do have a virtual one online that you can use. And then it ends with a campus debris survey. So I have them use, we use survey 1, 2, 3, and we do a campus cleanup. And then the kids, they create maps for each of these sections. And at the end, they put them together into a story map. And I'll just show you one of the story maps that a team created a couple years ago that they actually entered in the Skills USA competition, which is for career technical education classes. And they actually won gold for on the national level for this. And it's not loading. Oh, here it is. Oh, good. Slow Wi-Fi figures.
Well, maybe worst case, Tom, you can drop the URL in the chat window.
I gave Charlie all the URLs.
Oh, good. Okay.
Okay. Yeah. So I just had them do the lessons that was provided by Noah and do the background research, and then just take it a step further and come up with their own pictures and turn it into a story map. So the first one, there wasn't a map, but they got to, this is a video, which I won't play right now. They made a beautiful story map out of it. And then the CSV file of all the satellite tracking, they made that into a map, which is slow. Here it comes. Wait for it. There are dots in there. The third lesson talks about science and technology, where they talk about the satellite tracking and trackers and how that works. And they put a nice picture of Dawn up for that one. Then there was a hotspot analysis. In this one, they got to analyze why the birds were spending the most time. And I had them use a feature, the seafloor geomorphology seafloor feature, and had them look at what seafloor features are these birds gravitating towards. And then with the bolus dissection, they just plotted the point on the map where the albatross bolus came from. We used, and then they dissected it and analyzed the data.
I'll tell you what, Dom, we're since we're starting to run short on time, why don't we go ahead, especially if the audience has the link, and pass this on over to Eric. I think if he's still ready, and
still here.
He is still there. That's good. Thank you, Dom. That was great.
Sure.
And let's make sure we get the URL out to the crew. It looks like maybe.
Yeah, I wanted the URL of the gallery because there's just so many projects that people could look at.
We'll put those out in the end. Yep, we got them.
Eric, do you have screen? There you go.
There we go. Hi, I'm Eric Cromwell, Coordinator for Elementary Science for Baltimore County Public Schools. Hopefully you're hearing me and my bandwidth will hold up. The project I'm going to talk about is our 5th grade BioBlitz program. We've had an outdoor education program in Baltimore County at the elementary level for about 18 years now. And it was revised about 8 years ago when we transitioned to the next generation science standards. And what we wanted to focus on was really biodiversity, because there's a whole series of NGSF standards that talks about the movement of matter through an ecosystem. And in order to facilitate that movement, you have to have a diverse ecosystem. And so we sent students out across the county to one of 7 county or state parks, and they were using GPS-enabled tablets. We've bounced back and forth, but we've pretty much settled on Samsungs at this point as our tablet of choice. And they basically go through and sample every living thing they can find. And to date, we've collected about 30,000 points of data. Prior to this past year, we were using Collector for that, and was very happy to transition to Survey 123 because that saved us. I mean, the amount of time that has saved us has just been unbelievable. Collector got a little janky towards the end, and at least on the tablets we were using, but Survey 123 has really cleared that up. So what you're seeing here is actually our transition last year. Because of COVID, we couldn't take students out to parks. We had to do schoolyard bioblitzes instead, which was great because that also coincided with the great cicada hatch we had. The ProjExtractT came out this year, and so we had kids running around outside looking for cicada and documenting those as they found them. So let's see if I can get the good picture up here. We have, yes, we actually had a couple of emergers getting out there as well. And so students, when they collect the data with a survey, they identify it by, is this an insect, a bird, a mammal, a reptile, an amphibian, or a decomposer. And we really emphasize, or a plant. And we really try to make sure that even though the plants and decomposers aren't as exciting as the creepy crawlies, that they're probably more important than the creepy crawlies. And so we've actually set up kind of a quasi scavenger hunt to see if we can't get students to collect all those points. So this fall, we were hoping to transition back to going to our parks because of the bus driver shortage and substitute shortage. We are now back to doing schoolyards, which is fantastic because by the end of the school year, we will have sampled data at all 112 of our elementary schools across the system. So that'll give us a baseline data set for all the schools. And then the really cool part is in the app that's there, this is our data analyzer, and I've given the link to Charlie to get to everybody. The students actually use this data to compare the schoolyard biodiversity, which is up here, to the park biodiversity. And at this point, just to give you a comparison, our park biodiversity, we're at about 30,000 points of data. So there's just for plants alone, we have about almost 9,000 points we've collected of plants in the area. And on schoolyards, we're catching up. We're at about 4,500 there. So it's been an exciting project for us, and the students actually drill down to their schoolyard to see where things are living, why they're living there. And so the school year actually opens up with a schoolyard survivability unit or sustainability unit, where they look at that data, analyze it, and the goal of their entire day trip with us is to see if the biodiversity on their schoolyard matches or is less than the biodiversity in the parks that we visit. And then their job at the end of the school year then is to try to do some sort of habitat improvement project to increase biodiversity or maintain biodiversity on their schoolyard. So this project we do every year with all 8,000 of our 5th grade students. So we get a wide data set with the kids, and it has become the highlight of the students each year. And we've been seeing a lot of results from that. So I'll toss it back to Tom now since he's turned his camera on. That's kind of the hook, I think.
This is awesome, Eric. I mean, this is, you said 30,000 data points, huh?
Yep.
It's amazing.